right, so we're doing part of 5.1, which we just got finished with bisectors of triangles. So we're just doing part of this. So a perpendicular bisector in a triangle align a segment or ray that passes through the midpoint of a side and is perpendicular to that side. So you're looking for this again. So midpoint here. Okay. All right, so perpendicular bisector. So if we're trying to prove something, this is what we should know. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. Equidistant. All right, which makes sense. So here's our point. That means from here to here is the same as from here to here because it's the bisector. Okay. The converse of that, if a point is equidistant, from the endpoints of a segment, then it becomes a perpendicular bisector. So if these two are perpendicular and you have something here that's bisecting, then this would be the bisector. This line would be the bisector. And you're always looking, when you're thinking of those perpendicular bisectors, again, that's this guy. That's what you're looking for. All right, so let's go down here. Let's try some of these. These aren't too bad. Find B to C. So if this is B to C, if these two, then these two would be the same as well. So this and this would be the same. Toot, toot, toot. So BC, side BC, is equal to AC. Therefore, BC is equal to 8.5. Next one. Find X to Y. Well, since this is the bisector, that means it's dividing in half. So XY is equal to YZ because of the bisector, and therefore XY is equal to 6. Don't you wish it was always this easy? Let's try this next one. Okay, again, since we have this bisector, these two are the same as each other. So let's make them equal to each other and then substitute it back in to find PQ. So 3x plus 1 is equal to 5x minus 3. Go ahead and solve yours. I'll solve mine. PQ. Second, make sure everybody got 7. And a chance to catch up here. All right, let's flip. Point of concurrency. Point of concurrency is the point of intersection of concurrent lines. Point of intersection of concurrent lines. So concurrent lines are 3 or more lines that intersect. Again, here I am. There it is. Okay, so these are called circumcenters. Okay. The perpendicular bisectors of a triangle intersect at a point called the circumcenter. That is equidistant from the vertices of the triangle. So in this case, you are looking at A to D, B to D, and C to D. All of these are congruent. So this to this to this are congruent. Okay. So E, why did I say E? I don't want to say E. I want to say, where did I go? A to D is equal to B to D, which is equal to C to D. And they have them marked here, the little hash things. Maybe we should kind of highlight that a little bit more. Okay, so that's the circumcenter. Circumscribed. Okay, that's also showing the circumscribed. Okay, moving on. There are three ways that a concurrent lines intersect at the circumcenter: inside, outside, or on the triangle. So inside, it'll be inside of a circle if it is an acute triangle. So it must be an acute triangle. Perpendiculars at points M, N, and P. All right, so those are your bisectors. So that means that this, and this are congruent. A, D, B, D, C, D are all congruent to each other. Okay? If you have an obtuse triangle, so all of these were small, acute little angles. This one we have, it's hard to see the triangle, but the triangle's right here. So you're looking at this angle right here as being obtuse. So if the case is that you have an obtuse and your midpoints are M, P, and N, okay, that means your circumcenter really would be EX, DX, and FX. So everything going towards the center, towards that center. Okay? I don't know if we do as many as these. On a right triangle, same sort of thing. So we have these points, and then all of these that are going towards it, YN here, let's mark them. XN, that way you can see them better, and ZN would all be congruent. And it probably wouldn't hurt if we outlined those so you can see them a little bit better. Okay. Moving on. So we have this lovely triangle-shaped garden. Can a foundation be placed at the circumcenter and still be inside the garden? Well, you have an obtuse, so my circumcenter is going to be up here, correct? Just like at the picture over here, right? We've got this obtuse, it would be way up here. So this would be no. Obtuse triangle. Let's look down here. Point P is the circumcenter. Okay. List any segments congruent to MY. So here and here, because of this, so that's YE. Where's KP? So KP is here, right? So this should be the same as MP, this one, and then EP, this one. MN is the same as NK. So this one would be the same as this one. NK. Okay. I'm not necessarily saying that this is the same as this. It's a whole different thing. Okay. These are not equal to those two or those two. That's not given yet. Okay. Is there anything else? I think that's it. So that was pretty easy, short and sweet. All right. Let me know if there's any problems with the Google Forms. And we did that pretty quickly.